Today, we're going to talk about the anatomy of a computer. We've already talked about some of the history of the computer, but now we're going to talk about what actually goes into making a computer work. What is a computer? You can think of a computer of lots of different things, as long as it can receive information, process information, and then output information. So there are computers in your cars. There are computers in your watches. There are computers in your cell phones. There are computers in your iPads. There are computers in your automatic dog feeder. They're just, everything nowadays tends to have a computer in it. We aren't going to spend too much time on the history of a computer because we already did that. But just as a reminder, the first computer was the abacus, and it was one of the earliest devices, dating way back to like 3000 BC. From there came our mechanical calculators. So those came around in the mid to late 1600s. And began the concept of computing. Then our first electronic computers came about, and those computers kind of started in the 1940s around World War II. And these used vacuum tubes, so they were really big and they were really slow. But then in the late 1950s through the 1970s, they kind of transitioned, the electronic computer transitioned to using transistors and microchips, which helped speed things up. The transistors replaced the vacuum tubes, and therefore computers were able to be smaller and faster. The microchip in the 1970s is what allowed personal computers to start to happen. So, fun fact that a lot of people don't know, PC stands for personal computer. So, the first personal computers were introduced by Apple in 1977 and IBM in 1981. And these made computers accessible to the public. Before the old school electronic computers, those took up entire rooms. And all of that led us to the modern day computer, which is what we've got today, and that now includes smartphones and internet and AI and all of those things, and it's just going to keep changing and evolving. There are the main components of a computer. You've got your CPU, which is your central processing unit. That's like your brain of your computer. It processes information and it makes the decisions. Then you've got your RAM, or random access memory. That's your temporary storage. So think of it as like your short-term memory. It stores your data temporarily to give you quick access to it. Then you've got your hard disk drive and your solid state drives. Those are your long-term storage. That's where everything gets stored for the duration and remains there permanently. Then you've got your motherboard. Your motherboard is the main circuit board that connects all the components of the computer together. It's kind of like the spinal cord of the computer. So it helps just bring all the parts together and make them work quickly. The main difference between a hard disk drive and a solid disk drive is the hard disk drive uses spinning disks to store your data, so it's slower, but it's also much cheaper, versus a solid state drive has no moving parts, but is much faster and more durable. So if you're wanting to do a lot of video games, graphics, video editing, you're going to want your solid state drives. So we talked about the CPU. It's like the brain. You've got to have it, and it's going to really determine a majority about your computer. The role of the CPU is to take instructions from the software, calculate that data, and then generate an output. So that's what the CPU does. And if you think of it like a car, the CPU is like the brain in a person or an engine in a car. The faster the CPU, the quicker the computer can think and respond. So think of opening a game. A CPU decides how fast the game is going to run. So if your game's running really slow, a lot of times that's because it's taking the CPU longer to process that data. There are 4 operations of the CPU. First, the CPU has to fetch the information, so it gets the information from the memory. Then it has to decode the information and understand what needs to be done. Then it needs to execute that, so that's where it carries out the tasks. And then it needs to repeat this, and it does this millions of times per second. This is happening so incredibly fast on today's computers. There are 2 different types of CPUs. There's a single core CPU, and there's a multi-core CPU. A single core can only process one task at a time. It's slower when running apps, but it's good for simple tasks like Google Docs or browsing a game. But it's really bad for multitasking and things like gaming. Whereas your multi-core, it processes multiple tasks at a time. It's better and faster for multitasking. And these processors are great for video editing, graphics, high performance tasks, and gaming. But they are more expensive and they do use a lot more power. There are lots of different types of CPU, but they predominantly fall into 2 brands. There's the Intel brand versus the AMD brand. The Intel, so the i3, i5, i7, i9, they're more powerful and they're more power efficient. They're great for everyday using, whereas your AMD CPUs are more affordable and great for gaming and multitasking, but they do go through a whole lot more power. So I want you to take a break right now and think of how many computers can you think of that you use in your daily life. Okay, now we're going to talk about RAM. RAM stands for Random Access Memory. When you think of RAM, think like the desk. It's like the desk where you sit at to do your homework. If you have a big desk, you can spread out all your books and you can work a lot faster. If you have a small desk, then you can only keep a few books open at a time and you have to keep putting things away. so that the RAM can keep working. The more RAM your computer has, the more tasks that it can handle and do at the same time without slowing down. RAM is your short-term memory for your computer. It stores temporary data that the CPU needs to use right now. Then it goes from the CPU to your hard drives, whether that's a solid state or a hard disk. There are different types of RAM. There's dynamic RAM and there's static RAM. So DRAM versus SRAM. DRAM is used mostly in computers because it's fairly cheap and it can hold more memory, but it is slower because it does have to constantly refresh its data. Whereas an SRAM or a static RAM, it runs faster and uses the CPU as caches. That's CACHES, not cash like the money. These are more expensive and have less data. Really is, how fast does your computer run? So if you think about it, if you have 4 gig of RAM, that's going to be really good for browsing the internet and typing up a Word document. If you have 8 gig of RAM, that's going to be good for having open the internet while also making a PowerPoint, while also maybe having a casual game up like solitaire or chess. And then when you get to 16 gig of RAM and over, that's when you can get into your more advanced tasks with graphic creation and video editing and higher end gaming. When you're talking about video editing and computer coding and all of that, you want as much RAM as you can afford. Now we've got our solid state drives and our hard disk drives. Hard drives are where things go like a filing cabinet to be stored forever. So a filing cabinet or a box or whatever, they're there forever. So the bigger the cabinet, the more you can store. Or the bigger the box, the more you can store. That's the same with hard drives. The bigger the hard drive, the more you can store. So when you've got larger files, such as video files, graphic files, things like that, you're going to need larger hard drives. At a basic computer now, you typically see about 500 gigabytes as being the basic like intro computer. So knowing that the hard drive is the long-term memory of your computer, it stores everything: documents, pictures, music, games, the operating systems. Unlike RAM, these hard disk drives do store the data even after you turn off your computer. So when you've got a hard disk drive versus a solid state drive, it is all about how they operate. So a hard disk drive is what we're going to talk about first, an HDD. With these, you have spinning disks or platters that are moving in an arm and reading and writing. So think of a disk spinning really fast in a circle. The platter rotation inside the hard disk drive and metal disk spins really fast, like thousands of times per minute. And then magnetic writing happens as it moves over the spinning disk using magnetism to store all the data files into zeros and ones, which are binary data, which we'll talk about later. Then, when you want to retrieve a file, the head has to spin again to the right spot, then read that pattern. The hard disk drive finds empty space on the disk and writes new data there. So I kind of like to think of hard disk drives as like an old school record player. The pros of a hard disk drive: they can store a lot of data for a really low cost. The downside is they're slower because they have moving parts, and they're also less reliable because they have moving parts. Solid state drives have no moving parts and use just electronic memory or flash memory. Data is stored as electrical charges, so instead of spinning disks, a solid state drive stores data in tiny electric cells using electrical charges. These electrical cells still charge things in binary data, meaning zeros and ones. You can have faster access since there's no moving parts, and files can load almost instantly. So if you're doing gaming, if you're doing video, your solid state drive is really the way to go. The pros of solid state drives are they operate much faster, and they are way more durable and last longer because they don't have moving parts. The biggest con is that they're a lot more expensive. Next, we're going to talk about the motherboard. And the motherboard is basically like the spinal cord. It connects everything together. So if you think about your input devices like your microphone, your camera, your mouse, your keyboard, those are kind of like your arms and legs. They can do different things. You can also think of so the motherboard is also what plugs in your speakers, your monitor, and anything that is going to put out data. So your brain, your CPU, sends signals to these arms and legs and organs. So your RAM, your storage, your input devices, your graphics card, to do different tasks. Then the motherboard is what connects everything so that they can work together. So the motherboard transfers power and data between components and has lots and lots of different ports and monitors. So again, if you want to think about it, something around you every day, think of it kind of like a power strip. It has lots of different slots for you to plug in a lot of different devices. That's the same thing that a motherboard does. So as you see here on this picture, there's lots of little holes and soldered on items for connecting input and output devices for your computer. There are different types of motherboards. There's desktop motherboards and there's laptop motherboards. A desktop motherboard can be more easily upgraded, so you can add more CPUs and RAMs and GPUs. The ports are larger and do tend to need more power, whereas a laptop motherboard is much smaller much more energy efficient and portable, but very hard to upgrade once it's already in the computer, and it has way fewer parts. So before we go on, I want you to take a second and think about, do you think your computer has a large or a small motherboard? And I want you to draw a motherboard with its parts, with at least 3 parts connecting to it. Now we're going to talk about input devices. Input devices are things that come into your computer and put data into your computer. Microphones, cameras, mice, keyboards, all of those things. Take a second and write down all the different input devices that you can think of as you look at your computer. Now we're going to do the same exercise thinking about output devices. Output devices are what displays the information or presents the information. So that includes our monitors, our speakers, our printers, our projectors. Take a moment and write down the output devices that you see connected to your computer right now. There are also external storage devices. So these are what you hear often called as like a jump drive or a flash drive. You also can just hear them be called as an external hard drive. They come in lots of sizes and shapes and capacities. So there are a couple key things to look at when you are looking for an external device. Is you want to think about, how much space do I need? So like an 8 gigabyte flash drive is good to 1 terabyte is good for like small files. Whereas larger files and video files, you're going to want an external hard drive that's at least 500 gigs to 10 terabytes. The larger the storage amount, the larger the price, and the price increases and decreases based off if you're using solid state or hard disk drives. You also need to pay attention to the read and write speed. So the read and write speed on a external hard drive tells you read, how fast is this hard drive going to be able to read the information. And write is how fast is this hard drive going to allow the computer to write the information onto that hard drive. So again, the higher the read-write speeds, the higher the price, but also the higher the efficiency. So if we're putting this all together, you can think of the computer and all its parts kind of like a sports team. You've got your CPU, which is the coach. It's giving the instructions and it controls everything. Then you've got the RAM. That's kind of like the players, the short-term memory. It holds the important game strategies for you to use to quickly perform plays. You've got your storage, your hard disk drives and your solid state drives. That's like your playbook. It keeps all your past strategies and leaves space for you to add your future strategies as well. Then your motherboard's kind of like your team captain. It connects all the players so they can work together. Your power supply is the energy source that fuels the system. So it's kind of like your Gatorade and your pre-game meal. And then your input and output devices, they're like the communication of your team. So that's what allows the team to communicate with each other. So it's just another way to kind of think of a computer in a more tactical, everyday form. I hope this helps. After watching this, you're going to complete you're going to complete the next thing on your playlist. And remember, you can always come back and listen and watch for this again.